Welcome to the first problem in the 2025 AIME 1 problem series. In this problem, we want to find the sum of all integer bases greater than 9 for which 17 base b is a divisor of 97 base b. So writing this in mathematical notation, in order to figure out what base b satisfies these, we need to convert both of these into base 10. And so 17 base b is the same thing as b plus 7. 97 base b is similarly 9b plus 7. And so this is given by multiplying each of the digits of 17 base b and 97 base b by their respective placements of the powers of b. So for example, here we multiply 1 by b to the first and we get b. We multiply 7 by b to the 0 and we get 7. 9 by b to the first, we get 9b. 7 by b to the 7 times b to the 0, and we get 7. And so basically, we can write this as an equation. And so 9b plus 7 over b plus 7 must equal k for some positive integer k. And that shows that this divisibility will in fact be true. And so the best way to go about this problem is to split this fraction into two separate fractions. And even though that might seem a little bit complicated, the motivation behind doing that is that one of the fractions will become a positive integer, and the other fraction is going to be much easier to deal with. And so the way we do this is we write 9b plus 7 over b plus 7 as 9b plus 63 over b plus 7 minus 56 over b plus 7. And so what this does is now we have a fraction that is equal to an integer. 9b plus 63 over b plus 7, this is equal to 9. And so in order for 9 minus 56 over b plus 7 to be a positive integer, given that 9 is already a positive integer, we just need 56 over b plus 7 to be a positive integer. B plus 7 needs to be a positive integer. And so here at this point, we're just searching for factors of 56. If we divide b plus 7, if b plus 7 happens to be a factor of 56, then k1 is going to be a positive integer. So what we can do is we already know b is going to be positive by the condition that b is greater than 9. So let's go ahead and list out some numbers or some factors of what b plus 7 could be. So b plus 7 could just be a factor of 56. So the choices we have are 1, 56, we have 2, we have 28, we have 4, we have 14, we have, what other factors are there? I believe, oh yes, 7 and 8. And so a great way to check that these are all 8 factors of 56 is by just taking the prime factorization of 56. And what we can do is by taking the prime factorization and looking at the exponents, you can tell how many factors a number has. And so 56 is equal to 2 cubed times 7. And so what we do is we add 1 to each power in the prime factorization of a number. And so, for example, here, I'm taking 3, I'm adding 1 to it. I'm taking 1, I'm adding 1 to it. Then I multiply these numbers together. So I get 4 times 2, which is equal to 8. And so that shows that we have 8 factors of 56, and these all are the 8 that we are supposed to be accounting for. So let's go ahead and try each of these. Well, first of all, we can eliminate about, I would say, 4 of them right off the bat, or 5. Let's look at 1, for example. If b plus 7 is equal to 1, Well, then b has to be negative. B is equal to -6, so b cannot equal 1. If b plus 7 equals 2, same thing, b would be negative. B would be negative for 4, b would be 0 for 7, and b would be 1 for 8. And the condition states that we must have b is greater than 9. So now another thing, oh yeah, there's one more. B plus 7 cannot equal 14 because if it does, b will equal 7 and b will not be greater than 9. So now the only conditions we have for b plus 7 is either b plus 7 equals 56 or b plus 7 equals 28. So the first one gives us 56 minus 7 is 49, and the second one gives us 28 minus 7, which is 21. And so adding both of these up, we get that our answer is going to be 70. Thank you for watching.